What's up, interweb? Today we're going to be graphing quadratic functions. I'm telling you, I think this sounds like a disease. It really isn't so bad. It's just, it's really different from a lot of things that you've done before. But it's not particularly difficult. Quadratic functions are always in this form. I know always is a long time, but they're in the form ax squared plus bx plus c, where a, b, and c are numbers, of course. But a cannot be 0. The graph of a quadratic function are parabolas. Now, parabola is a kind of a U-shaped thing, either going up or down, with a vertical axis. And what does that mean? I'll show you in just a second. Here it is here. Okay, this is, excuse my horrible drawing. This is a parabola and it has a vertex. The vertex is on the bottom, the very bottom, or in case of a parabola that opens downward, it's at the very top. Now, what we talked about with a vertical axis, excuse me, is this. Now, if this was drawn properly, yeah, right, like I'm going to draw anything, right? This axis of symmetry, you could fold this parabola over. This one appears probably a little bit better. This would be the axis of symmetry. What does that mean? Symmetry. It's the same on the right as it is on the left. You could, if you were to fold this along the axis of symmetry and fold it over, this side would be exactly on this side. And I'll show you how that works in just a second. Okay? So those are some new terms. Again, this is not particularly difficult. It's just different. So if you have a quadratic function, the quadratic function is, let's say, f of x. Remember, f of x is the same thing as y. We just write it this way. The function of x is, let's say it's x squared. And we have another quadratic function that says f of x equals x squared minus 2. Now remember, I told you that these things are always in the form ax squared plus bx plus c. Well, what happened to the b and the c on these? On this one, they're both 0, and on this one, the c, our c is -2. We just don't have a b function. We'll use some simple ones here just to give it a look. Okay, so what if we have x, in other words, some numbers. Let's do -2, -1, 0, 1, and 2. If you'll notice, they're just opposites of each other. Now for the first one, f of x equals x squared. And then this one over here will be f of x equals x squared minus 2. Okay, when x is -2, okay, plug in -2. -2 squared is 4. -2 times -2 is a positive 4. Same thing here. When x is -1, -1, we plug in -1 here. -1 squared is 1. 0, of course, is going to be 0. And then, excuse me, when x is 1, 1 squared is 1. And here we have x is 2. 2 squared is 4. If you'll notice, these numbers are exactly the same as the ones at the bottom are the same as at the top. Now this one, we have x squared. So we plug in negative 2 here. Negative 2 squared is 4. 4 minus 2 is 2. Same thing here. Plug in negative 1. Negative 1 squared is 1. 1 minus 2 is negative 1. Plug 0 in. 0 squared, of course, is 0. 0 minus 2 is negative 2. And plug 1 in here. 1 squared is 1. 1 minus 2 is negative 1. Plug 2 in here. 2 squared is 4. 4 minus 2 is 2. Now, let me plot these. Negative 2, 4. 1, 2, 3, 4, 5. 1, 2, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay? So negative 2, 4. 1, 2. And up 4 would be about here. Negative 1, 1. Negative 1, 1 is here. 0, 0 is right there. Now we have 1, 1 is here. You'll notice that they're exactly the same. And 2, 4 would be about here. Now if we draw our parabola, and it will go on forever. Okay, that's that one. Now you can see, even as bad as my drawing is, that now where is the axis of symmetry? The axis of symmetry is going to be the y-axis. And there's the vertex. The vertex is there. Axis of symmetry. Axis of symmetry is the y-axis in this case. Okay, now this one, that was a negative 5 there, and so was that. 1, 2, 3, 4, 5. Negative 5. Okay, so we have negative 2, 2. Negative 2, 2 is about here. Negative 1, 1. Negative 1. Stupid boy. Negative 2, 2 is here. We're doing this one. Now, we finished with that one. Okay, negative 1, 1 is here. Now we have 0, negative 2. 0, negative 2 is here. 1, negative 1. 1. Wait a minute. What did I do here? Negative 1. Stupid boy. Not here. Here. There. And then 1, negative 1. 1. Negative 1 is here. 2, 2, 2, 2. And our parabola goes like that. Axis of symmetry, again, is the y-axis. And our vertex is here, and that's at 0, negative 2. That's the vertex. Okay. Now, hallelujah, we can do this stuff on our graphing calculators. You know what? Hang on just a minute. Let me go and get my graphing calculator. I'm going to do this on my graphing calculator. Remember, the first thing you do is turn it on, and then we go to y equals right up here. And we're going to do this function right here, and hopefully it will look like what we drew here. But you know how my drawings are. Okay, f of x, in other words y equals x squared. And remember, x is not this. This is the multiplication key, not the variable x. The variable x is up here where it says xt, theta, and n. So we have x and then x squared. Always double check and look and make sure you entered it correctly. Now here's our graph. And sure enough, it looks dangerously close to what we drew here, where the vertex is at the very bottom and the axis of symmetry is the y-axis. Okay, go back to, now we're going to do this one, x squared minus 2, and it should look kind of like that one. So I'm just going to arrow over minus 2. Okay, it's just minus and the number 2. Now we'll go to graph. Sure enough. And you can see now the axis of symmetry here is the kind of like, it's the dividing line between, and if you look, the distance between the axis of symmetry and here is the same as it is here. Go to y equals, clear it out, turn it off, and like that. Okay. Now, how do we find the axis of symmetry? There's a nice pretty formula. The axis of symmetry is negative b over 2a. That's the axis of symmetry. This is, if you'll look on these things, where is the axis of symmetry? It's the x coordinate. D-I-N. So in other words, if our parabola looked like this, the vertex would be here, the axis of symmetry would be here, which is roughly 1, 2, 3. So the axis of symmetry on this one would be 3, 0, or 3, y. All these numbers. That would be, that's what the axis of symmetry is actually x. It's the x coordinate. Let's see what else. This is the x coordinate, and to get the vertex, remember the vertex is the very bottom or the very top of a parabola. Now to find the vertex, remember that's going to be xy. That's going to be a point. It's going to be this point right here, or this point right here, or this point right here. That's the vertex. Now that will be in the form of xy. To calculate the axis of symmetry, or calculate the axis of symmetry, and remember that will give you the x. Now to find the y, then plug the x into the original equation and solve for y. Now remember, y is the same thing as f of x. And that will give you the xy, or the vertex, the bottom or the top of the parabola. Now, there's another thing here, not super whiz-bang important, but you're probably going to see this on the final. It's called vertex form. Now, vertex form is f of x, or y, equals a open x minus h closed squared plus k. And again, a cannot equal 0. This is the vertex form. Now, if you have, isn't this fun? This is good stuff here. Okay. Let's get a drink of Diet Coke before I pass out. Mm-hmm. Okay, for example, f of x equals -2 open x plus 3 all squared plus 4. So therefore, 3 little dots in a triangle, our vertex is -h and k. So -3, okay? The thing says -h, so we do the opposite of whatever's here. So -3 and k is 4. Okay, that's the vertex. And if we were to draw that, the vertex would be -3, 1, 2, 3, and 4. 1, 2, 3, 4. So our line of symmetry is going to be right here, or axis of symmetry. So where's the axis of symmetry? S-Y-M-E-T-R-Y. Axis of symmetry, remember, is just x. And where is x? -3. Now, I'll tell you what, here, let me graph this thing for you. Maybe it'll make it a little. First you turn it on, and you go to y equals. Now we're going to put in this equation right here in vertex form, just the way it is. The calculator will deal with this. So remember, when the negative is at the beginning, we have to use this negative key down here, not the subtract key. So we go -2 open parenthesis x plus 3 closed squared plus 4. Okay, let's double check to make sure we're right. -2 open x plus 3 squared plus 4. Yes. Now we graph it. Okay, now you see this one opens downward. if you have the function, if I sent you a sheet on this, and I'm going to go over this again in just a minute. If it's if f of x equals x squared plus bx plus c, this is positive. If this is positive, it opens upward. If f of x equals negative x squared blah 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 blah, it opens downward. Now, where is our vertex? Our vertex is right here. Or let's find the axis of symmetry. 1, 2, 3. You can see that it goes right there. Now what you can do is you can trace. Hit the trace key, and you can see the little cursor. You can also see down here at the bottom x and y. So if you arrow up, where am I? I'm going the wrong way. What have I done? Okay, where is the cursor? Let's see it. There it is. Well, you can't see it because I've got a little booger looking thing on there. Yeah, it's not going to give us the exact thing, but you can see the numbers down here. X is negative 2.97, blah, blah, blah. That's dangerously close to negative 3. And our Y value is, I can't read it, 3.07. Anyway, that'll give you the, you can do the trace thing, but it's not, it probably will not mimic, or it's probably not going to follow the parabola exactly. Anyway, okay, so that's our formulas. Okay. Now remember the vertex form, V-E-R-T-E, vertex form. I don't think you're going to see this a whole lot. Vertex form is f of x equals a, open, x minus h, closed, squared, plus k. So if you have f of x equals 4, open, x minus 2, closed, squared. Okay, so what's the value of k here? Oops, sorry. I'll do better. Okay, so if you have this, f of x equals, this is in vertex form. So what's our value of k? We just don't write it because we don't have to. Lazy mathematicians. So our vertex, V-E-R-T-X, is, remember, negative h. So the opposite of negative 2 is 2, and k, which is 0. And what is our axis of symmetry? Remember, it's just the x function, or the x coordinate. So our x is 2. Okay? Let's graph it and see. Turn it on. Y equals Now remember, the calculator will deal with this the way it's written. 4 open x minus 2 closed and squared. And that's all. Don't have to put in the plus 0. Graph it. Now you can see the parabola comes down and touches the x-axis in one place. And where is that? At 1, it's at 2. Okay, the vertex is 2, 0. Remember, the vertex is the very bottom. And the axis of symmetry is this, right up and down, which is 2. Okay? Okay. I sent you a sheet on this. I hope it makes sense. Remember, quadratics are always in this form. Ax squared plus bx plus c. Okay. If a is greater than 0, what numbers are greater than... Oh, bonehead. I'm sorry. I'll do better. No, I'm not going to do any better. Probably. Now, what numbers are greater than 0? Positive numbers. If they're greater than 0, then the parabola opens upward. And if a is less than 0, in other words, negative numbers, the parabola Rabola will open down. Okay? Now, if b is greater than 0, it's going to shift. The parabola will shift. Parabola. The parabola will shift to the left. It does exactly the opposite of what you'd think it would do. You'd think if positive it would shift to the right, but it doesn't. It shifts to the left. And if b is less than 0, in other words, negative numbers, the parabola will shift to the right. Now, okay, now remember, if a is less than 0, it opens down. Now what happens to the values of b? And that's if a is less than 0 and b are positive numbers. Now it's going to shift to the right. And if b is less than 0, it shifts to the left. Okay? And if you're not sure, plug a couple of them into the calculator and see what happens. Now c, remember, f of x equals ax squared plus bx plus c. C is just like in the linear equations, c is the y-intercept. But remember, parabolas kind of go like this. There's the y-intercept. It really doesn't have anything to do with the vertex or anything else. It's just the y-intercept. Okay. Oh, one other thing. The smaller A is, the wider the parabola. P-A-R-A. P-A-R, stupid boy. B-O-L. Okay, the smaller A is, the wider the parabola. And of course, the larger, L-A-R-G-E-R, A is, the narrower the parabola. Right? Right. Okay. So if you had something like, well, let me show you. Turn it on. Y equals, if we have 5x squared, we'll just do that. You can see how narrow that is. And we go back to y sub 2, and we're going to put in 0.25 x squared. Now that's going to be real wide. Okay? And of course, the same thing holds true if the numbers are negative. They'll just open downward. Same thing. All right, that's basically it. This calculator is your friend. All right, y'all take care. Bye-bye. Bye, bonds.